Hello guys, welcome to S Academicus. So in this video I'll be explaining what is weak beam and strong column. So this concept is basically used in your buildings, RCC buildings designed for seismic resistance. So I'll be explaining what is weak beam and strong column. So let's get into the problem, the topics. So what is strong column and weak beam design? A strong column weak beam is one of the concepts involved in designing earthquake resisting structures. As the name implies, the beam should fail first, then the column. So I'll just explain this with the help of this concept. I'll just go to the topic. So what exactly is strong beam and a weak column concept? So for the concept is like your beam will fail first and then your column. So once your beam fail, it will give you enough sufficient this warning so that you can just get that thing done. So let's talk about, like, this is your column, this is your frame of a building, so this is your beam and this is column. So when you're this during earthquake, this lateral base shear will act, then this should fail first. So if just assume this beam has been failed, so how this will become, this will be like there will be a break in this. So due to the ductility of reinforcement, there will be some connections. So when you apply this lateral thrust, so this direction the displacement is allowed, like at least up to some certain extent displacement is allowed. So based on that allowed displacement, your building is not going to collapse completely, like it is not going to have a cascade fall, that is, it is not going to collapse completely, but your beam will fail and then it will show enough warning. So if the severity of earthquake is very high, then you can easily evacuate the building and can save human lives. So this is the concept of, so this beam column should be strong column, and beam should be weak in the sense the moment capacity, I'll explain in the later slides. The moment capacity summation of MB should be less than summation of MC. So this is the concept. It is not like you have to design the beam weaker, or you have to just ignore the stability of the beam. You just need to take that concept in mind, like your column should be strong, that moment capacity of that column, because beam we are designing for moment capacity. So the moment capacity of column should be greater than the moment capacity of beam. So let's get into the problem. So this is the problem. So we'll just have a look on this beam and column moment capacities. So to avoid progressive collapse of a structure due to cascade effect created by column failure in the lower levels, the column and beam are to be designed as per strong column and weak beam design, which I have explained just now. This helps the structure to dissipate seismic energy better without total collapse. I said the displacement in that direction is more. So let's get into that topics. That is, these plastic hinges formed in the beams of plastic hinge, when seismic earthquake will occur, the plastic hinge will be formed in the beam first, then it will increase the ductility of the structure, and hence the structure would be able to undergo lateral displacement, which I have said that if your beam fails, then based on that base shear, your lateral displacement will be more. So now how can we do it? As per IS 1392, I have already considered this. The moment capacity of your column should be greater than the moment capacity of your beam. So for that, we have to design the beam first and then the column first. So to ensure that columns are designed for higher moment capacity. Once your moment capacity of beam is identified, then you calculate the moment, then your column shall be designed for higher moment capacity compared to your beams. So let's get back next to the next slide. So this is the typical concept of your strong column and weak. The plastic hinges should form in the beam first, not in the column. So if your column is forming plastic hinges, then it will have a cascade fall. So this was regarding your strong beam. strong column and weak beam. This is a simple. So in this graphical representation, we can just see these are the moment capacity of this column, moment capacity of this column, moment capacity of this column and this column. So moment capacity of beam. So that the summation of moment capacities of all the columns should be greater than the summation of moment capacities of all the beams. That means your beam, as we have said, your beam need to be designed first, and then based on the moment capacity of your beams, your column need to be designed. So this is the concept for weak beam and strong column, or strong beam and weak columns. So this is a typical numerical problem. I have just copied it from internet just to show the values. Like this is the same representation with a numerical value. So you can see the moment capacities of column MC and MB. So after summing up all the moments of these two frames, this MC is 8380 and MB is 8040. That means your moment capacity of column is more and moment capacity of beam is lesser than your beam column. So this is a strong column and weak beam design. So this is a typical cascade failure where your column was weak and the beam was not. The building has not been designed for a weak beam and strong column. Here weak beam does not mean that you are compromising the design of your beam and you are compromising the design of your column. This is a concept, means you are based on the design, the moment capacity of your beam. Like if your moment capacity of beams is 180 kilonewton meter, the moment capacity of that column should be more than 180. Whether the moment coming, the design moment is lesser than 180, but you have to design your column more than 118 because of this concept for your earthquake resistance buildings. So in case if you have any doubt regarding this topic, in case you have any conceptual issues regarding this topic, we can definitely try to comply. We can definitely try to clarify your doubts and we will try to include, if certain topics need to be included regarding your doubts, we can definitely include. So this weak beam and strong column concept, I think, is very clear to you. If you have any doubts, you can anytime raise your queries. Thank you. Have a nice